The final section in Chapter 7 is inverse relations and functions. All right, so a composition of inverse functions. We talked about a composition last time. So we have this function f, and its inverse we're going to denote by f to the negative 1. If they're inverses, then if we composite the inverse with the function of x, we should get out x. And then the same thing is true if we composite the function with its inverse, we should still get out x. All right, so if a relation maps element A, let's call this element A, of its domain to element B of its range, then the inverse maps B onto A. Okay, let's talk a little bit about the notation. So in order to write the inverse function is denoted by this f to the negative 1. But this isn't like an exponent or anything. We're not going to raise it to the negative first power. This is just notation. Okay, so if a function f pairs a and b, or a with b, then the inverse must pair b with a. So b with a. So it must pair b with a. All right, let's find the inverse of a relation. So all we're going to do to find the inverse of a relation is just switch the x's and y's. So here our x's are negative 1, 0, 1, 2. Our y's are negative 2, negative 1, and 2. We're just going to switch them. So all of these that were y's are now our x's. So negative 2, negative 1, negative 2. And then what were the x's are now the y's. So here were the points for our original relation. We've got negative 1, negative 2. There's that point. 0, negative 1. 1, negative 1. And 2, negative 2. So all of those points line up with these. So let's graph this one. Okay, so now we have negative 2, negative 1. So negative 2, negative 1. Negative 1, 0. Negative 1, 0. Negative 1, 1. Negative 1, 1. And finally, negative 2, 2. So negative 2, 2. And what you'll notice is an inverse basically makes this line, it mirrors this function across. So before this was a function, remember our vertical line test, it doesn't connect at any more than one point if we use a vertical line. This is a function. Its inverse is not, because look at this, we connect with 2 points right here. So this inverse relation is not a function. Let's take a look at how we would do this without all of the points to map. All we're going to do is change x and y and then solve for y again. So let's rewrite this. Only every y is now an x, and every x is a y. And now we just have to solve this for y, get y by itself. So what we're going to do is we're going to add 2. So x plus 2 is y squared. And now to undo squaring, we take the square root. And I'm going to move this y over here. So y is the square root of x plus 2. But keep in mind, anytime we do that, we need to think about this could be positive or negative. So here's our original function, and here is its inverse. All we did was switch the x and y and get y by itself. Find the inverse of this function. So here's our function. If we want to find the inverse of it, first of all, this is our y. Now we're just going to switch x's and y's. This was a y, it's now an x. This was an x, it's now a y. So now we're going to try to get that y by itself. We first need to get rid of that square root sign. So what do? We square both sides. This side became x squared. This side, the square root and the square undo each other, so we got 2y plus 2. Now all we need to do is subtract 2, so we get x squared minus 2, and divide by 2. And we got all y all by itself. So this is our inverse of this function. So the inverse function is x squared minus 2 divided by 2. All right, so they wanted us to find the domain and the range. Domain are the x values that we could have, and range are the y values of this function. All right, so this thing in here can't be negative because we can't take the square root of a negative. So that means that 2x plus 2 has to be greater than or equal to 0. If I subtract 2 on both sides, I get that 2x has to be greater than or equal to negative 2, and then x has to be greater than or equal to negative 1. I just divided by 2. So, since the radicand, remember that's the thing underneath the radical, can't be negative, the domain is the set of numbers greater than or equal to, oh, well, what are they equal to? Negative 1. Okay? Since the principal square root, that's the square root, is non-negative, meaning it could be 0 or positive, the range is the set of non-negative numbers. So all the things that we could get out of here could either be 0 or positive numbers, non-negative. All right, they want us to find the domain and range of this function now. So the domain equals the range of the original function. Remember, because A maps onto B, then B maps onto A, which is a set of non-negative numbers. Okay, and so since this thing has to be greater than or equal to 0 because it's being squared, then this thing has to be greater than or equal to negative 1. Because the smallest this could be is 0. If this is 0, then we get negative 2 divided by 2. Well, that's just negative 1. So this thing must be bigger than negative 1. So the range of the inverse is the set of numbers greater than or equal to negative 1. That makes sense because that was the domain of our original function. So the range of the inverse is the same as the domain of our original function. All right, so finally, is the inverse a function? So for each x in the domain of this, there's only one value. So if I put a 0 in here, 0 minus 2 divided by 2, that's negative 1. If I put in a 1, 1 minus 2, which is negative 1/2, whatever I put in for x, there's only one output. So this inverse is a function. All right, we have one last thing to do. This is the composition of inverses. Well, look back at the very beginning. It said that if we composite the inverse with the original function, this was the inverse composited with f of x, then it was equal to x. And if we composite the function with its inverse of this, it would be the same thing. So we don't even have to find the inverse of this. We don't even have to plug this giant number in. We know that this thing is equal to this x because they are inverses of each other. So that's just equal to 652. And this is just negative square root of 86 by definition of what an inverse is. So I want you to go ahead and do these quick checks that are left on here. I'll scroll up, you can pause. There's one of them. And there's the other one.